All right, let's take a look at section 9.5, the sine and cosine ratios. In 9.4, we took a look at the tangent ratio, which hopefully you now know is the opposite over adjacent. Now, we have these two other ones, sine and cosine. Now, some people look at sine and they say sin. It's not a sin, and cosine is not cos. Maybe because of the calculator, that's all you see, but sin is actually sine, cos is actually cosine. All right, so let's get that out of the way and not get confused. Because you don't want to sound like a fool when you tell someone, hey, what's the sin of 55 degrees or something like that. So sine is opposite over adjacent, or sorry, tangent is opposite over adjacent. For sine, it's going to be opposite over the hypotenuse. And that right there is the sine ratio. The next one for our cosine ratio right here, that's going to be adjacent over the hypotenuse. And so in mathematics, we have like stupid little sayings that we use to try to help us memorize things, acronyms. And we have like, please excuse my dear Aunt Sally, for to try to figure out what the order of operations are. For these tangent ratios, the stupid thing that we say right here is SohCahToa. All right, so let me go ahead and put this down for you. So SOH, sine, opposite over hypotenuse. We have C for cosine, and then we say Ka for adjacent over hypotenuse. And then we have T, and Toa is opposite over adjacent. So we have right here SohCahToa. Use that to help you memorize it. It's been used for ages, so it's one of those things that your parents probably heard at some point in time, if they had taken geometry or even some trig classes back when they were in high school. So once again, SohCahToa, use that to help you memorize the different sides that go along with sine, cosine, and tangent. All right, so that right there should be a little device to help you out with that. In 9.4, we talked about the angle of elevation. In this section, 9.5, we're going to talk about the angle of depression. Now, depression, we usually think of being down. So that's exactly how we're going to see this. If we have a person right here at the side, and he's looking, this person, he or she or whatever, is looking down at an object. Let's say this is at the top, and they're looking down at, let's say we have a tree right here. Okay, so looking down at the tree from atop of the mountain. Okay, the angle of depression is the angle where this person is actually looking down at the tree. Now, here's the common misconception, though. The misconception is that people think that the angle of depression is this right there. And that's not correct. No, that is not the angle of depression. The actual angle of depression will be setting up the triangle upside down, and this right here, I'll put a check mark and I'll put yes. And that is your angle of depression right there. So it's important to know the correct location and spot for the angle of depression so you can get the problem correct and understand where exactly it's supposed to be. All right. So let's go ahead. Let's take a look at our core concepts. And so we're looking at the sine and cosine ratio. And I pretty much already talked to you about SohCahToa, right? Once again, I'll put it down. SohCahToa. And if you look at the expression that's given, it says sine of angle A is equal to opposite over hypotenuse. And once again, if we look at SohCahToa, sine opposite over hypotenuse. So, all right. So I could use the sine of A on any of the acute angles or that are in a right triangle. So I could say sine of A, or I could also say sine of B when we take a look at this triangle here. I could also do the same with cosine and cosine of A. I can go ahead and realize, hey, that's adjacent over hypotenuse. And I could say cosine of A or even cosine of B, depending on what sides they give us or what side or angle I want to actually find, other than the 90-degree angle, which is the obvious one. All right. Moving along. When we get to the examples, I'll show you how to put everything together, but it's actually very similar, or it's almost the same as using, the tangent ratio and just plugging in the correct sides into the correct part of the ratio. So we have the sine and cosine of complementary angles, okay? What they're saying here is this: the sine of an acute angle is equal to the cosine of its complement, okay? Our complementary angles are two angles that add up to 90. So if one angle happens to be 10, the complement of it would be 80. And so it says if I were to take the sine of an acute angle, for example, sine of 10, that is equal to the cosine of 80 degrees, is what they're saying, the complement. All right? So therefore, they put right here the sine of angle A is equal to the cosine of angle A, or taking 90 minus that angle, and that equals cosine of B. And we could go ahead and repeat the same process. The cosine of angle A is equal to the sine of 90 degrees minus angle A. And there you go, sine of B. So let's put this all together. Okay, let's take a look at number one. They're saying let's find sine of F, sine of G, cosine of F, and cosine of G. You want to write things as a fraction and as a decimal rounded to 4 places. Remember, if they ask for you a answer that is exact, then you're not going to use your calculator. You're going to have to make sure you know how to plug the sides in correctly. So let's go ahead and start right here. We don't know what the angle is other than we know that we're looking at angle F. So I'm going to put sine of F. And remember, once again, SohCahToa. I'll put it up right here. SohCahToa. And so sine is opposite over hypotenuse, right? And if I take a look at angle F right here, opposite of angle F is 12. And the hypotenuse is opposite of the 90-degree angle, which is 13. Okay? So there's the first part. Sine of F, 12 over 13. We round it to 4 spots. It's 0.4231 using your calculator. I didn't press the sine button in the calculator. All I did was just put 12 over 13. All right. So next up, we have sine of G. Once again, sine is opposite over hypotenuse. If I take a look at G right here, opposite is 5. The hypotenuse is 13. And that right there gets us approximately 0.3 3846. So we figured out the sine of angle F and angle G. Next up, let's take a look at cosine of F and cosine of G. So let's go ahead and start with F. And if I take a look at angle F again, I'll put cosine of F. And SohCahToa, cosine is adjacent over hypotenuse. So the adjacent would be 5. Hypotenuse is 13. Now remember, students oftentimes, the mistake that I'll see is they put 13 as the adjacent because it is right next to it. However, there's a more specific answer for that side, and that is the hypotenuse. Okay? And so we got 5 over 13, which is approximately 0.3846. And then we have ourselves cosine of G, and that will be adjacent, which is 12. Hypotenuse is 13. And this is approximately 0.9231. All right, so there you have that right there. Okay, so it's just pretty much knowing your, what side's opposite, what side's hypotenuse, and opposite and adjacent, and so on, when you're using sine and cosine. All right, so let's go ahead and move on right here. And let's take a look at number 4. It says, write the expression in terms of cosine. Okay, so they're saying that, remember, we learned about the sine and cosine of complementary angles. And so what we can do right here is say that the sine of 9, that is equal to the cosine of, well, 90 minus 9. So this is going to be equal to the cosine of 81. Remember, these two are equivalent. Cosine of 81 and sine of 9 are equivalent. And if you were to actually put that in your calculator, you'll realize you get the same answer. All right. So let's take a look at number 5. The sine of 30, that is equivalent to the cosine of 60. Why? Because if you take cosine and then you take 90 minus 30, that's how you get that number. Last, right here, sine of 77. This right here will be the cosine of, if you take 90 minus 77, then you get yourself 13. And there you go. We have found the expressions in terms of cosine. Can't do that for tangent. Okay, this only works for sine and cosine. So if we take a look at number 7, we could write cosine of 15 in terms of sine by going ahead and taking sine, and then I'll put 90 minus 15, and so we end up with sine of 75. So there's number 7. Number 8, maybe I'll give you a moment to do that. And hopefully right here for 8, you end up with sine of 7. All right. I think we get the picture now. Hopefully after doing these, we'll skip number 9. So now let's get to the real good stuff of this section. Okay. The meats of the section. Find the value of each variable using sine and cosine, and we round your answer to the nearest tenth. Okay. So if I take a look at what's given to us, I've got an angle right here, 16 degrees. And I want to try to figure out x and y. If I want to figure out x, remember, what they do give us right here happens to be the hypotenuse, and that right there is being opposite. Okay, so what do? Remember, we have our SohCahToa. And I look at the parts that are highlighted, opposite and hypotenuse. Well, which one has opposite and hypotenuse? It's the sine ratio. So that's why right here, what I'm going to end up doing is I want to go ahead and put sine of 16 degrees, because now we know what the angle is on this one. And that's going to be equal to opposite over hypotenuse. So x over 9. So our job is to find x. So let's get x by itself. Let's go ahead and use some of our algebra right here. I'll multiply both sides by 9. And x is equal to 9 times sine of 16. Don't forget, when you plug that into your calculator, you may have to make sure that your calculator is in degrees mode, not in radians. So when you go ahead and plug that into your calculator, we round that to the nearest tenth, you get approximately 2.5. Practice it, boys and girls. Okay? Make sure you might have to put this right here, the sine 16, in parentheses or in a bracket so that you can get the correct answer. All right, so there's that right there. Now, let's take a look next at y. Okay, if I take a look at y and I'm looking at y is adjacent, and what they give us now is the hypotenuse of 9. Okay, so which one has adjacent and hypotenuse? Looks to me that's the cosine. So right here, next up, we have cosine of 16. That's equal to the adjacent, which is y. Hypotenuse is 9. Okay, so then we go ahead, we'll multiply both sides by 9. You got y is equal to 9 times cosine of 16, and that is approximately 8.7. Now, there's one big caveat to all this. You may say, when I solve for cosine, okay, or when I solve for y, I could technically use x, which I now know is 2.5. And I could use 2.5 and 9, opposite over hypotenuse, and say sine 16 is equal to, or sorry, I could use adjacent and opposite, which is tangent. And you're saying, hey, why don't I use the tangent one? I have 2.5 and I have the adjacent. Or I'm trying to find the adjacent. I don't recommend that, because then what you're using is a rounded number to help find another answer that's going to be a rounded number, right? Because 2.5 is actually rounded to the nearest tenth. So for the sake of being accurate as possible, I do not want you to use rounded numbers more than once, or use rounded numbers more than one time, or sorry, just use it at all. There are ways to find these answers without using an answer that's already rounded, unless you're able to use the exact value. And if you were to use the exact value, then you would be using 9 times sine 16 instead of 2.5. Okay, so if you can, when you're doing these problems, make sure you do not, use rounded numbers to help find an answer for another side or angle. Okay, that would be very helpful for you. Let's go ahead and take a look at, let's see, what else looks like it might be challenging for you guys. Let's take a look at number 13. It's all about the same. Let's go ahead, right here in 13, we got to find, if we're trying to find A, we have A and that side right there, which would be considered the opposite of 65 degrees. Okay, why is it not the hypotenuse? Well, remember, you can see the right angle, and opposite of the right angle is B. So side B is your hypotenuse, actually. So let's see what we can do right here. All right, so if I have adjacent and opposite, okay, I look at SohCahToa, adjacent and opposite happens to be tangent. But we're not supposed to use the tangent ratio, okay? They're asking us to use sine and cosine. Now, in the next section, you can use whatever ratio you want. But today, because they want us to use sine and cosine, and what we could end up doing right here is figuring out, well, what happens to be, how do I figure out, what side A is with 65? When side A is the adjacent and 25 is the opposite. Well, remember, we could figure out that third angle right here. Okay, I know one of them is 90, the other is 65. So if the total angles in a triangle are 180, then I could figure out what this other missing angle is. And what does it happen to be? It is 25. So what I could actually use this time is this angle of 25 to help me come up with my answer. And then we have right here 25. We've got opposite over adjacent anyways, right? So depending on how you want to look at the problem, you could do either or to help you find your answer. Okay? So right here, let's just go ahead. We'll use the tangent ratio, even though I said, all right, let's not do that. So let's see. We'll just do the 65 actually. Let me go ahead and erase this. So we have tangent of 65, and I'm using tangent because A is adjacent, and then 25 is opposite. So we're going to go ahead and put 28 over A. We're going to have to do a little bit of algebra right here, do some reorganizing. We'll multiply both sides by A. And then, in order for us to get, we got A times tangent 65. That's equal to 28. I now have to divide both sides by tangent 65. And right here, A is equal to 28 over tangent 65. All right. So you can go ahead and plug that into your calculator. I'll plug that into mine right now. And I get approximately 13.1. When you round it to the nearest tenth. All right, so there you have A. So then how about B? Okay, well, side B is the hypotenuse and 28 is opposite. So which one has opposite and the hypotenuse? That will be sine. So for this one, let's go ahead. We could find the sine of 65. SohCahToa. Opposite is opposite is 28. Hypotenuse is B. And so let's go ahead, solve for B. We'll do the same, pretty much the same steps as what we just did to solve for A. We'll start multiply both sides by B. B times sine 65 is equal to 28. And then let's divide both sides by sine 65. So B right here, let's plug that into the calculator. 8 divided by sine of 65. And I get 30.89. Well, that 9 will take that 8 and move it up. So we get about 30.9 right here is side B. Please make sure you guys show your steps like how I'm showing it here in the examples. Okay? It's good practice. There's a lot of things going on as far as trying to solve these problems out. So show your steps accordingly. And I'll thank you in advance. All right. Let's go ahead and take a look at the last problem right here. We got this word problem. A camera is attached to a kite filming the damage caused by a brush fire in a closed off area. The camera is directly above the center of the closed off area. So it says right here, the person is standing 100 feet away from the center of the closed off area, and then the angle of depression of the camera to the person flying the kite is 25 degrees. So how long is the string on the kite? Well, that's kind of interesting, right? It says the angle of depression from the camera, okay, to the person flying the kite. So let's think about this. If I were to draw this out, I've got a kite, right? And they're saying that remember, the camera is up on the kite. the angle of depression from the camera. Okay, so if the camera is up here, we have the kite slash camera. Okay, if the kite and camera is up there and it is going downwards, right? Remember, so think we have a straight line right here, and the string is going down like this. Don't forget the angle of depression is going downwards, and that angle of depression right here is 25 degrees. And so what they're saying is that this angle that I just wrote and I put information down, that happens to be your angle of depression. It says, how long is the string on the kite? Well, how do I figure that out? Well, once again, let me tidy up this diagram. If the person happens to be right here flying the kite, remember, they said that the person is standing 100 feet away from the center of the closed off area. So this length right here is 100. And hopefully you're able to figure that part out. Right? We've got ourselves our 90-degree angle. And then it says, well, how long is the string on the kite? And the string on the kite would be right here, which I marked up as, which would be your hypotenuse. So based off of what we see right here, we've got SohCahToa, right? Well, how am I going to use sine, cosine, or tangent to find x? Well, if I look right here, I've got adjacent and hypotenuse. Right? 100 would be adjacent to 25. X would be the hypotenuse. So that means that I better be using cosine. So let's go ahead and set this up. We have cosine of the angle, which is 25 degrees, is equal to adjacent. And hopefully right here, you got the adjacent down as 100. Hypotenuse is x. All right? Not the other way around. The x is not the adjacent side. It's opposite of the 90-degree angle. So we'll go ahead and multiply both sides by x. And then let's divide both sides by cosine of 25. Okay, I'll go ahead and just kind of do both right here. I would not recommend it. So here, let me go ahead and rewrite this. So we got x is equal to 100 over cosine of 25. So we'll go ahead and put that in right here. 100 divided by cosine of 25. And we get ourselves approximately 110.3. And that right there, and we'll put feet, that is the length of the string of the kite. Okay? Let's take a look next at letter B. One last part right here. It says if the string on the kite is 200 feet away, how far must the person flying the kite stand from the center of the closed off area, assuming the same angle of depression of 25 degrees to film the damage? Okay, so let's see. Based on the given information, let's draw things out. We've got our kite and camera, right? And if the string is 200 feet long, so this time they're giving us like this hypotenuse. They're saying that the hypotenuse is 200 feet. Same angle of depression, right? This angle of depression right here is still 25 degrees. And then it says, how long is that string, or how long is the person standing away? And x will now be the adjacent part. Okay? So let's go ahead and repeat the process. We got cosine of 25 is equal to adjacent, which is x. Hypotenuse is 200. And so now we're finding what x happens to be right here. And then we'll go ahead Multiply both sides by 200. And everything works out nicely. And x is equal to 200 times cosine of 25. And so let's see right here. 200 times cosine of 25. And this now happens to be 181.3 feet. And that's how far the person needs to be away from the damage based off of the given length of the kite or the string of the kite. Okay? There you go, section 9.5, sine and cosine. Remember, SohCahToa.